Okay, here we have the GBR model. We have salinity on the left and we have temperature on the right. On the left you can see the normal outflow of the rivers. These mostly a small wet season flow. We've got two rivers down the bottom, the Herbert and the Burdekin. You see there's not at the moment a terrible lot of water coming out of there. Then the temperature, we're coming up to a relatively hot period in January, and we can see the daily heating and cooling of the Great Barrier Reef going on. Close to the shore we have the hottest waters, and we have this daytime heating or nighttime cooling. Starting at the shore with these waves heading out into the deeper water. Then as we get through in towards the start of February, we'll start to see the event of the effect of a flow event. First of all, in the salinity side, if you watch carefully, you'll see like a flash of water, and this is the arrival of the storm, just hitting the area and depositing its rain straight into the water. There's that rain there coming in on the top. There's that high intensity system delivering rainwater straight into the ocean. Now this, and you can see immediately these rivers in the smaller catchments along the Cairns to Cardwell Coast, these sort of wet tropics, being hit. Then that storm proceeded further south inland into the catchments of the Herbert and Burdekin, and then you can now start to see water coming out from the Herbert and Burdekin. This is the Herbert down near the island, which is Hinchinbrook Island, and then further to the bottom you can see the Burdekin. This water really starts to flood the inner lagoon, and it's sort of pressed up against the coastline by a northerly current that's pushing everything north and holding that water against the coastline. You can see all in the central GBR here around Mission Beach is very lots of fresh water. And then what happens is this northerly current suspends for a small amount of time and allows the water to flood out into the reef. This is what you're seeing here. So the northerly flow current has stopped, and then this fresh water flows right out into the whole continental shelf of the GBR, and this was the cause of lots of damage from freshwater inundation, lots of freshwater bleaching. A coral nursery died, a clam nursery died that's been there for 40 years. All the clams died overnight down to about 5 metres. But what the model showed is that the water was floating out on top. It was actually confined to the top 5 metres or so of the water table, of the water column. So that enabled these rivers to have a much larger extent of influence, because they weren't being immediately dispersed in the area adjacent to the river mouth as previously thought, but rather they were floating out on top of the salt water, enabling this water to reach far out into the outer Great Barrier Reef before being deposited down onto the substrate. So it's quite a revolutionary discovery and quite interesting. If you had something like this running inside the Red Sea, it would enable you to sort of fill in the gaps of what happened in your bleaching events, and also get warnings, because this model runs in forecast mode up to 14 days ahead.